In this video, we're going to talk about solving logarithmic and exponential word problems. One application of logarithms involves the pH scale in chemistry. The pH of a substance is a measure of the acidity or alkalinity of the substance. The lower a substance's pH level, the greater the acidity and lower the alkalinity. The higher a substance's pH level, the greater the alkalinity and lower the acidity, the reverse. Now, the formula for pH is pH equals negative log H plus, where H positive, I should say, is the concentration of hydrogen ions in moles per liter. Okay, so determine the pH of a substance if the concentration of hydrogen ions is 0.000067 moles per liter. Well, that's like saying that this H positive number right here is 0.000067. Well, negative log of that quantity is equal to negative 4.17. Because if you use your calculator to evaluate log of 0.000067, you'll get negative 4.17. With that extra negative sign in front, the pH is 4.17, and we can give our final answer. That is the pH. Determine the hydrogen ion concentration of a liquid with a pH of 8.6. Well, in this case, what we'd be saying is that 8.6 is equal to negative log of H positive. Well, that would be like saying negative 8.6 is equal to log of H positive. Now remember, when you don't see a base on log, the base is 10. So we're really saying negative 8.6 is log base 10 of H positive. Well, that we can rearrange to say 10 to the exponent negative 8.6 equals H positive, like that. Okay, so we can say that we're talking about approximately 0.0000000025 moles per liter, right here. And that's our hydrogen ion concentration. All right, now, if we consider the hydrogen ion concentration of a liquid to be a measure of the strength of an acid, how much stronger is an acid that has a pH of 3.4 than an acid with a pH of 4.8? Well, let's find out. So to determine how much stronger acid 1 is than acid 2, we need to calculate the hydrogen ion concentration of acid 1 and divide that by the hydrogen ion concentration of acid 2. In other words, the H positive of acid 1 over the H positive of acid 2. Well, pH is equal to negative log H positive. So in the first situation, we would say 3.4 is equal to negative log H positive, which would mean negative 3.4 equals log H positive, which would mean H positive is 10 to the exponent negative 3.4. That's the hydrogen ion concentration of the first acid. By similar thinking, the hydrogen ion concentration of the second acid, there's a little typo here. It should say 10 to the exponent negative 4.8. That's the hydrogen ion concentration of the second one. So putting the first H positive over the second H positive gives us 10 to the negative 3.4 over 10 to the negative 4.8, which is 10 to the negative 3.4 minus negative 4.8, which is 10 to the 1.4. 10 to the 1.4 is approximately equal to 25.1. So what we're saying is an acid with a pH of 3.4 is approximately 25.1 times stronger than an acid with a pH of 4.8.